everybody, Dr. Doyle here, and I am here today to talk to you about equivalent systems. And the best way to really explore what equivalent systems are is to do an example. So I have reproduced here an example that you can find in your lesson sheet, and we're going to go through it together. And our goal here is we are going to try and replace this system, which has these two 40-pound forces, which you should recognize quite easily here as a couple moment, and a 60-pound force acting at an angle of 50 degrees. We want to replace it with just that 60-pound force at an angle of 50 degrees. And that's going to have to be acting somewhere different than it is on this system. And we want the box that I'm showing here, this 25 square inch box, to feel the same under each scenario. And that feeling of sameness is what we call an equivalent system. Okay, so let's start by looking at this top one, and we're just going to find the resultant force and the resultant moment about some point, and then we'll go from there. So let's start on this top one by finding the total moment about point A and the total force. So the total moment about point A, the total force in the Y, and the total force in the X. Okay, so we'll start with the moment about point A, which is this point here. You may recognize this as a couple moment, and of course we can see, if that is true, that the moment produced by those two forces together is going to be 40 pounds times the distance between them is 25 inches. And we need to make sure it's positive or negative. It is going to be going in the negative direction, so that means a negative sign. And then the 60-pound force, the Y component, is going to add to the moment about point A. That's going to be going in the positive direction, so we will have 60 times sine of 50 times that distance of 25 inches. And if you do this, you're going to get a total moment about point A of 149.1 pound inches. And I'm going to show that that would actually be going in that positive direction. Okay. What about the sum of the forces in the Y? In the Y, we have only one force. We just have that 60 times the sine of 50, which is 45.96 pounds acting up. Okay? And then in the X direction, I'm going to write out all of the forces. So I have 40 pounds, that's that top one. Then I subtract out 40 pounds, which again shows us that this was a couple moment. And then I'm going to add to that 60 times the cosine of 50, which leaves us with just that one component, 38.6 pounds, and I'm going to draw that direction there. Okay, so this gives us the total moment about point A, 149.1 inches, and the total X and Y component. And now I want to determine where I could move this 60-pound force acting at 50 degrees so that it feels the same. It has the same X component of force, the same, I did that opposite, the same Y component of force, the same X component of force, and that same total moment. So the first thing you should notice is right off the bat, if I'm still using that 60-pound force at an angle of 50 degrees, that my sum of the forces in the X, in this case, were already there. It's already just 60 pounds times the cosine of 50, or 386.16, and the same for my Y. It's already 60 pounds times the sine of 50, which is that 45 49.96 pounds acting up. So now all I need to figure out is that moment, okay? We know that we want the sum of the moments about point A to be equal to 149.1 pound inches, so that it matches this number here. Which of these two components is contributing to that moment about point A? It's only the y component, right? So that 149.1 pound inches needs to be equal to 45.96 times some distance x, okay? And so I can solve for my x. It's going to be 149.1 pound inches divided by 45.96 pounds, which gives us an x of 3.24 inches. So if that 60-pound force acting at 50 degrees above that horizontal is acting just 3.24 inches from point A, then this system is equivalent to this system. Let's define here what we mean quickly to sum up by equivalent system. So an equivalent system is a system of forces and moments that make a body feel the same total force and moment. Okay, so that is the definition of an equivalent system. And so what it means is that this plate or this box under both of these scenarios is going to try and translate the same, and it's going to try and rotate the same. Okay? If you looked deep into the molecular level of the material, it would look different, but when you look at the system as a whole, that's where it's going to feel the same and be equivalent. All right, so that's an introduction to equivalent systems. We'll keep practicing this concept together, and I'll see you in the next video.